Assalamu alaikum and good morning, students. I hope all of you are safe and happy. Today we will discuss a rule-based verification, refinement, and validation. So, what does it mean? In our last class, the expert system development methodology, you have observed that in every stage of expert system development methodology, we are designing a prototype, and that prototype, after designing and developing, we are checking the prototype and testing the prototype. So how to check, how to validate, and how to improve the prototype. Now, this is the objective of today's class. So first of all, you will have to think about the prototype, and you can ask from yourself, or maybe you can discuss with your group members, that the knowledge that the prototype has is complete. You can ask this question, that the knowledge is complete, or every aspect of the knowledge is correct. Whatever knowledge we have brought into the prototype, is that knowledge correct? So, if the system knowledge is incomplete, so what are the complications? These are the problems that if the system knowledge is not complete, it may lead to an incorrect conclusion. Of course, if the knowledge is incomplete, then the conclusion will be also incorrect, or it may have a strange behavior. Or it may work in some cases, and in other cases it may be totally wrong. Okay, so these are the common issues when the knowledge is not complete. So in order to refine and improve the prototype, you will have to collect all these type of problems, and after that verify and validate the rule base again. So note the point, we are improving the rule base. Okay, that if there are any such type of problems, then we will have to improve, and this process will be continued, meaning to say, find the problems. Okay, what type of problems exist in the knowledge base, and then refine again. So how to find, what aspect we need to focus on, we will discuss today. So what is verification? We will think about the knowledge base, that the knowledge base is actually represent the domain knowledge completely or not. Okay, and if the domain knowledge is not totally represented in the knowledge base, then you will have to refine. So what to refine? The refinement are this, that you will correct bugs in the rules. What type of bugs, what are the possible issues, we will discuss later on. And then maybe dropping or adding some conditions in the rule. Maybe you can add new, or maybe you can delete some conditions, or maybe you can change the uncertainty factor. Okay, so these are the different issues that we can refine, and after that we will validate the system. You will ask from yourself, and you will think from this perspective, that the system does what it was intended to, meaning to say, for what purpose we design the prototype or the system, is that objective is achieved or not. Okay, and at an adequate level of accuracy. Not only achievement, the achievement should be at a high accuracy level. Okay, if achieved, so okay, if not achieved, then refine. Okay, so these the refinement of the system actually include many iterative process. The first step in establishing the reliability of an expert system is to verify that its knowledge base is free from anomalies. Anomalies means bugs or errors, such as redundant and conflicting or missing knowledge. Such anomalies are suggestive of errors in knowledge base. Empirical evidence suggests that the errors revealed by verification may be hard to detect by conventional system testing. So the conventional system testing actually cannot be applied on expert system. So verification can be performed automatically by domain independent anomaly checking tools. So meaning to say there are many tools available that you can check, that tools can be used to automatically check your knowledge base. Let me show you one research paper. That research paper actually suggests many tools. This I'm not going in the details, but if you just have a look at the table of contents, so you see here the automated tools. There are many tools available to check. You see the syntax checking tools, semantic checking tools, knowledge acquisition and refinement tools, intelligent compilers, and other dynamic testing tools, and summary of automated tools. So many tools are there that can check for you the problems in your knowledge base, and then to improve. So So what are the issues when we are trying to and validate our knowledge base? The first issue is that the expert system way of refining is not like the way that we can improve the conventional system. By conventional system means that the systems are softwares, maybe web development, maybe like your maybe any other tools, like for example applications that you have designed in Unity or in other applications. So what's the difference between conventional system and expert system? The main difference is that conventional systems are algorithmic based. A conventional system follows step by step rules, so you can easily go through that rules and that step or that algorithm, and you can find out problems. But expert system is actually not algorithmic, that is non-algorithmic, because expert system is based on a human expert, and you know that human brain is non-algorithmic. So this is the main difference, and this is the difficulty to find out bugs in a expert system. Another problem is that normal conventional system can be tested by test cases. We can design test cases for conventional systems. For example, if you want to test your algorithm or function, so you can provide the input values, maybe one time zero values, maybe one time negative values, maybe one time instead of numeric you provide string values. So you are testing by different alternatives, so you can see the behavior of a conventional system easily. But expert system, for the tests for expert system are different. You will have to depend on the domain expert, and the domain expert know from experience what are the possible cases to be tested. So the test cases for conventional system and the test cases for expert systems are different. Another difference is the explanation and the debugging. Expert system contain explanation, we have discussed in detail, okay, but conventional system has a debugging, and there are many debuggers are available. Every tool provide a debugger, so you can easily check. Second issue in knowledge base refining or validation is that these may be all different type of rules which can create a problems, like redundant rules, subsummed rules, unnecessary antecedents, okay, and so on. All these rules we will have to discuss, so you can check the knowledge base from all these perspective. So this is another aspect or another issues which can create problems, are another way from where we can improve the knowledge base. Okay, so these are the tools I already show you. The other paper also, there are many tools available that can be used to improve the knowledge base. Okay, so these rule, what does redundant rule mean? Redundant rule means that if any rule is duplicated, typed many times or two times, okay. For example, you see, if you look at these two rules, actually these two rules are 100% same. The only difference is that here this, that if it is an ostrich, then is false. So this component is actually uh, written in the second one first. So just the order is different, otherwise it is same. So if this type of rules are available in the knowledge base, it can create problem. So you need to find out redundant rules and delete the redundant one. And conflicting rules, for example, if you look at conflict, means that one rule is opposite to the other rule. For example, if you look at this one, you see that if, let's suppose, x is in a bird, okay, so if this condition is true, then the bird can fly. But if the bird is ostrich, then this condition is false. Okay, but okay, but in this case, you see here in the condition is that it can fly, but here in the second condition is opposite to this, so here is a false. So the same conditions, the same values, but in one case is true and in another case is false, so they are contradicting to each other. So this also create a problem. So this is a, you will have to find out such type of rules also. Subsumption rule means that sometimes some rules are a small component, sub-component of another rule. For example, here the rule number 8 is actually embedded in the rule number 1. So if it is already embedded there, so no need to rewrite again. So remove the subsumptions. Second one, another problem is unnecessary antecedents. Sometimes the conditions are, some conditions are actually unnecessary. Okay, so we need to remove that. For example, two rules have unnecessary antecedents. If one rule has a condition and the other rule has a negation of the same condition, okay, so in that case the two rule lead to a same conclusion. Okay, so you see these two rules actually conclude the same thing. So if they are concluding the same thing, so no need to write two type. Okay, so you can delete one because their conclusion is same. And a circular rule means is like this, it creates an infinite loop. Okay, for example, if you look at this, so the infinite loop will never conclude, it will never end. So if you look at this one, if a is true, then b will be true, and if b is true, then c is true, and if c is true, then a is true. So the loop go back again to a, so it become a circular rule, like a infinite loop. Okay, so this is also a problem, you need to remove this one. And unreferenced attributes, unreferenced attribute means that sometimes we have variables, okay, which have values. So we define a variable or we store values maybe in a working memory or in a knowledge base, that we never use that. Okay, we never reference those values. So if we never use it and it is there, so this also may create a problem, so need to remove. For example, in all these rules, if you look at this, so here the hot temperature is never used in the conditions. Okay, so if you are using, so these are the different values that the weather contain. For example, weather is cold, weather is normal, weather is hot. Okay, so some values are multi-valued, meaning to say the one variable may have different values at different times. So if you define such a multi-value attribute and you don't refer to all values in the knowledge base or in the rules, then this also create a problem. So sometimes this may be because of because of some typo. For example, you see here in this rule the heart is mistyped. Okay, so maybe because of the typo, or maybe because of copy paste that we sometimes do and forget and maybe make a mistakes. So this also can create a problem. And unreachable conclusions. Okay, sometimes we mistakenly design such a rules that the rule never concludes something. Okay, for example, if you look at this rule, in rule number 19, if A is true, then B is true, and if B is true, then C is true. So there is no conclusion. Okay, it also somehow mm, looping condition. Okay, but it never concludes something, so such rule also create a problem. And dead end if conditions are dead end goals. So for example, it means that if you have used, because we are using a rule based expert system, so if you are using if condition and you never end that one, okay, there is no end of the if. Okay, so it also create problems. And sometimes there is dead end goals. So in these rules, if you look at this, so it again doesn't reach to any goal, because if A is true, then B is true, and if B is true, then C is true, and if C is true, then D is true. So what's the conclusion? Again, no conclusion, or maybe dead end if conditions. So this also need to be removed from the knowledge base. Okay, so once you found all these type of problems, then you will have to refine. So what does refining means? Refining is adding or deleting the conditions or the conclusions in the knowledge base, or maybe increasing or decreasing the certainty, the uncertainty values. So once you found all these type of issues in the system, then you will have to delete, add, or modify. Okay, so this updating process is called refinement of rules. And after that, validating step comes. We find the rules, we refined that, and now how to validate, how to check that what we have done, is it correct now or still need further refinement. So for this purpose, an expert system can be validated by giving the same set of cases to expert system and to a domain expert. You will pick up one case and you will give to a human expert also, that how the human expert is solving, and you will give the same case to your experts system also, that how the expert system is concluding that one. So then you will match the both solutions. If they are same, then is correct. If they are different, it means that your expert system is again not like the domain expert. So you again need to go through your knowledge base. What's the problem? That it is not the same like the expert system. Okay, or maybe this is one way. Another way, maybe you can check, or you can give the case to different domain experts and then verify. Another way that you can check uh, prototype, you can check the prototype in a field. In a field means that you can bring your prototype to the real world problems. Maybe if it is related to medical, maybe you can check in a hospital, okay, or in a clinic, to the real world problems, that it can perform there or not. Then you will see that what are the issues. Or maybe you can check, you can test in a lab by real data. So these are the four different type of validation rules, that you will check what you have done now is okay or not, now is correct or not. And finally, remember that the validation never be perfect, meaning to say the validation process never ends. Every time it needs improvement. Any confusion, any question, Then you note the questions and we will discuss in a class.